Number 13. Consider the following table that gives the data for the golinator. So let's take another table. Again, I'm going to draw enough to go to the 4th degree if necessary. I don't think we'll have to on this one, but we might. So there's the X and Y's, and I'll make a space for the first consecutive differences. And the X's are the same, from 0 minutes to 6 minutes. And of course, I didn't make enough rows. That's the nice thing about tables, though. You can always add a row. And then we have 0, 1, 4, 9, 16. Well, might want to put a 5 in there, Amanda. And then 6 and 36. This is an interesting function. If I can remember at the end, I will show you the actual function that makes this. I believe this one's going to be a 3rd degree. But let's see. All right, so common difference or consecutive difference at the first level. 1 minus 0 is 1. 4 minus 1 is 3. 9 minus 4 is 5. 16 minus 9 is 7. 25 minus 16 is 9. 36 minus 25 is 11. So it is not common at the first level, which means it's not linear. There's definitely a pattern there, though. So I would suspect that this one will not be option E. Since there is a pattern, I think it's a polynomial function. It's just a matter of knowing which degree it is. And I have to sit up. I'm sliding down. I'm propped up in my bed, and this is just not the best place to do this. But anyway, so here is common difference or consecutive difference 2. 3 minus 1 is 2. 5 minus 3 is 2. 7 minus 5 is 2. 9 minus 7 is 2. And 11 minus 9 is 2. So it is common, and it is quadratic. So we were right. Wait a minute. Did I say this? I can't remember if I said, I thought it was going to be, I think I said it was going to be a 3rd degree, didn't I? It's a 2nd degree, and I'm going to show you the actual function. But it's quadratic. If I said 3rd degree, I apologize. I meant to say 2nd degree. Here's the function. The output, based on x, is equal to x to the 2nd power. In other words, if I put in a 1 for x, I'm going to get 1 squared, which is 1. If I put in a 3 for x, I'm going to get 3 squared, which is 9. If I put in a 6 for x, I'm going to get 6 squared, which is 36. So this one is quadratic, and I like that one. This is called exponential growth. And it starts off slow, but then it picks up speed and it grows very quickly. The higher that number of minutes climbs, the higher that total balls launched. is going to go in a hurry. All right, so we didn't have to go all the way out, and I like that. And was that the last one of those beauties? No. Well, it was the last one like that, but there is one more question about this story. And then we are going to leave this story behind. I still would rather have a story problem any day than a non-story problem. Consider the tables from 11 to 13. Which statement is true? The pitcher launched the greatest number of balls in 6 minutes. Well, let's do it this way. So here's A. The pitcher was the second one, wasn't it, that we did? No, it was the first one. So for 6 minutes, the pitcher launched 24. The volley at 6 minutes launched 63. And then the goalinator at 6 minutes launched 36. So this is the false statement. That should say the volley launched the greatest number in 6 minutes. The machine whose data can be modeled by a linear function dispensed the fewest balls after 1 minute. Well, again, I need to look at all three of them, and I'm just going to use letters. At 1 minute, the goalinator is right there in front of me, so let me do that one. At 1 minute, sorry. 1. The volley at 1 minute was 1. And then the pitcher at 1 minute was 4. This was the linear. This one was undefined. And this one was quadratic. The machine whose data can be modeled by a linear function dispensed the most balls after 1 minute. So this is a false statement. The machine for which there was no common consecutive difference dispensed the least balls after 6 minutes. Okay, again, those match up to this particular group of functions. At 6 minutes, the goalinator was at 36, 24, and 63. So the machine for which there were no consecutive differences launched the least. That's a false statement. It launched the most. D. The third consecutive difference for the pitcher is equal to the third consecutive difference for the goalinator. Well, if we go back to the pitcher, we didn't find the third consecutive difference. So we're going to need to do that. And I'm actually glad we're doing this because I want to show you something really important. 4 minus 4 is 0. 4 minus 4 is 0. This is going to be 0 all the way down. And that's second degree. If we go to third degree, we're going to get 0 minus 0, which is 0. And that's going to be true all the way down. So here's what I want to show you. After you reach commonality, everything else will be zeros. So if it's common at the first degree, it will be common for everything thereafter. So let's go back to this. D says the third consecutive difference for the picture. And we just found that that's 0. Is equal to the third consecutive difference for the golinator. So let's go to the golinator. We only went to the second degree, but once you reach commonality, once you've got a common consecutive difference, everything after that will be 0. So the consecutive difference at the third level is 0. So yes, this statement's true. Both of them are 0. The common consecutive difference for the golinator is more than the common consecutive difference for the pitcher. So this is saying that the golinator is greater than the pitcher. Let me redo that. The golinator's common consecutive difference is greater than the pitcher's common consecutive difference. So the golinator's common consecutive is 2. The pitcher's is 4. 2 is greater than 4. That's a false statement. So the one that we want to choose is D, as in dog. And I think I'm going to stop this video, even though we're not to the end of the page. This is getting to be a very long video. So let's stop it and then we'll finish up.